Okay, advanced math class, here we go. I got to do this quick because YouTube only gives us 10-minute videos. So starting with lesson 1, we're going to talk about complementary and supplementary angles. Lesson 1 has a lot of information in it. We're not going to be going over all of that at once. Use it as a reference lesson. Go back and look at it. But problem number 1 and 2 will ask you to identify complementary angles. Complementary angles are those angles that when added together make a right angle. So the complement of angle A is 90 minus angle A. Supplementary angles are those angles that when added together make a straight angle or 180 degrees. So the supplement of angle A is 180 minus A. So the complementary of angle A is 90 degrees minus angle A, and the supplementary is 180 degrees minus A. And then you can fit that into the story problem into number 1. Then, while we're on the geometry topics, we need to remind ourselves about some things about triangles. Remember that triangles have 3 interior angles. I'm going to label this triangle X, Y, Z. One thing we would know is that angle X plus angle Y plus angle Z will always add up to 180 degrees no matter what type of triangle you have. If you have an isosceles triangle, meaning that the 2 legs have congruent length, then we also know that the angles opposite those congruent legs are equal to each other. They are congruent. They have the exact same measure. So if I knew that angle Z, for instance, was 50 degrees, then I would know that angle X in an isosceles triangle is also 50 degrees. I could then figure out angle Y because 50 plus 50 plus angle Y would have to equal 180 degrees. Therefore, Y would have to be 80 degrees. So if you know the type of triangle, some basic rules about triangles, then you can solve for the missing parts, the missing angles of the triangles. Now you also are going to have some intersecting lines. Intersecting lines form angles. I'm going to label this angle A, B, C, and D. Intersecting lines form supplemental angles, those angles that add together to make 180 degrees, and it also forms vertical angles. Vertical angles are across from each other. Remember, D and B are vertical angles. They are congruent. D is equal to B in this case. A and C are vertical, so angle A is equal. I'm going to use congruent because I don't know their measures. Angle A is congruent to angle C. They have the exact same measure, whatever that measure is. They are congruent because vertical angles are congruent. And then you can see lots of sets of supplementary angles. B plus C is going to equal 180 degrees because together they form a straight line. That's supplemental angles. That will help you with problems 19 and 20, just reviewing some of those basic rules. For problem 21, you're going to need to remember something about parallel lines and transversals. If I have a pair of parallel lines cut by a transversal, it creates interesting angle relationships. That transversal makes acute angles and obtuse angles. All of the acute angles are congruent in measure. All of the obtuse angles are congruent in measure. Every set of one acute and one obtuse are supplementary. In this case, if I label the angles 1, 2, 3, 4, 5, 6, 7, and 8, we know that all of the acute angles, 2, 4, 6, and 8, have congruent measures. All of the obtuse angles, 1, 3, 5, and 7, have congruent measures. And therefore you could solve, if you know some of them, you can solve for the ones that you don't know by identifying these congruent angles and supplemental angles. Now these congruent angles have very special names, and we will be reminding ourselves of those and going over that in class. You might remember alternate interior, alternate exterior, corresponding angles, vertical angles. So we will be reminding ourselves of those in class, but that should help you with number 21. And number 22 3 parallel lines cut by 2 transversals creates line segments that have a proportional relationship. And this is 3, 4, X, and 8. Now we're not talking about angles, we're talking about line segments. This segment is 3 units long, this segment is 4 units long, this segment is X units long, this segment is 8 units long. The way we can find out what X is to know that this segment and this segment have a relationship in the same way that this segment to this segment is. So 3 is to X in the same way that 4 is to 8. Now we can solve a proportion, which is 2 equal ratios, by cross multiplying. 3 times 8 is 24. 4 times X is 4X. And then we can solve for X. You may have seen a much faster way, however, in which case still set up the ratio. You still need to show your work. 4 is half of 8. And so if this fraction is in the same proportion, 3 would have to be half of X. And so X would have to be 6. So you could have done it without the cross multiplying, but when they get more difficult with fractions and decimals, the cross multiplying works very well. The last thing I want to go over is something that was on your formula sheet from last year. You'll be getting a new one on Thursday, and that's the area of a sector. In problem number 26, we're giving a circle with a 40-degree angle and a radius of 3 times the square root of 3 meters. We know to find the area of the whole circle that it's pi radius squared. Hopefully remember that. But I don't want the area of the whole circle. I want the area of just that shaded sector. So I want just this fractional part of the whole. In other words, I want 40 degrees of the whole 360 degrees. So I want just that fractional part of the entire area of the whole circle. So you would have pi, your whole radius gets squared, the entire thing, times 40 over 360. You can then simplify that out by hand. I'm not going to take the time to do it here, but then remember that your answer is in meters squared because we're looking for area, and area is in squared units. Now, the last 2 problems, number 29 and number 30, are considered quantitative comparison problems. They used to be on the SAT exams. They are no longer on the SAT exams, but they're still great problems. What you need to know is that there will be 2 quantities when you are done. There will be quantity A and quantity B. How do you know what the answer is? If quantity A is greater, then A is the answer. If quantity B is greater, then B is the answer. If the quantities are equal, C is your answer. And if you cannot determine, D is your answer. And the book doesn't really tell you that, so you just kind of have to know. You'll get down to those last 2 problems and not know what to do. If your answer is either A, B, C, or D. After you've done the math and determined what the 2 quantities are, you compare the quantities. Quantitative comparisons. Okay, I will see you on Thursday. Don't worry if there's still some of these that you don't get on your own. I will answer questions. We will go over the exponent rules in class just to remind you of the exponents. Okay, we'll see you tomorrow.